Hello viewers, welcome to my channel and thank you for watching the videos and subscribing the channel. इस वीडियो में 2024 पेपर 1 का क्वेश्चन 1b कर रहे हैं. क्वेश्चन है let t such that r cube to r cube be a linear operator and b is equal to v1 v2 v3 be a basis of r cube over r. Suppose that t v1 is equal to 110, TV2 is 1 0 minus 1, TV3 is 2 1 minus 1. Find a basis for the range space and null space of T. 10 marks का question over R. Then let's take x1, x2, x3. Belongs to kernel T. Be arbitrary. x1, x2, x3 be arbitrary and they belong to kernel T. Then we can write T x1, x2, x3. अगर 1 to 1 है तो ये 0 होगा, 0 0 0. And T of x1 v1 plus x2 v2 plus x3 v3 is equal to 0 0 0. So we write x1 t v1 plus x2 t v2 plus x3 t v3 is equal to 0 0 0. And t v1 is given to us, so it is x1 110 plus x2 10 minus 1 plus x3 2 1 minus 1, and this is equal to 0. We find the equations x1 plus x2 plus 2x3 first term से. Then we have x1 plus x2 वाला term 0 है, and then x3. Then third is 0 minus x2 minus x3, and this is equal to 0 0 0. So we get three equations: x1 plus x2 plus 2x3 is equal to 0, x1 plus x3 is 0, minus x2 minus x3 is 0. So this gives, if we take x1 as 1 from here, so let's take x1, suppose x1 is 1, then x3 is also minus 1. And if this is the situation, then x2 will be, these will cancelled out, x1 plus 1 plus x2 minus 2 is equal to 0, so x2 is equal to minus 1, and then plus 1, x2 is plus 1, so we get 1 1 minus 1. We may take another set also. If we take x1 minus 1, then x3 is 1 and x2 will be, x2 is minus 1, so this is minus 1 and 1. So we get x1 x2 x3 as we have written here. In terms of x2 we can write, and in terms of x3 also we can write. So we write in terms of, let's say, x3, so minus x3 and x3, which has given this term, and they are representing the same thing. Minus we have, because we have assumed. So kernel T is equal to x3 minus 1 and 1, such that x3 belongs to R, and this is not equal to 0. Minus 1 1 is not equal to 0. So this is a basis of kernel T, and dimension of kernel T is equal to 1. Minus 1 is a basis of kernel T, and dimension of kernel T is equal to 1. And we know the formula, Sylvester's law. Kernel dimension of kernel T plus dimension of range T is equal to dimension of R cube. So dimension of range T is equal to 3 minus 1, it is 2. Now we show that TV1, TV2 belongs to range T are linearly independent. So let alpha TV1 plus beta TV2 is equal to 0, 0, 0 such that alpha beta they belong. So we can write alpha into 110 plus beta into 10 minus 1 is equal to 0, 0, 0. So alpha plus beta, alpha plus 0, 0 minus beta is equal to this. So alpha plus beta 0, alpha is 0, beta is 0. So TV1 and TV2 are linearly independent. Linearly independent subset of range T. Since dimension range T is equal to 2, since dimension of range T is equal to 2, TV1 is equal to 1, 1, 0, TV2 is equal to 1, 0 minus 1 is the basis of range 2, range T.